Hello and welcome back to Calculus 2. We are talking about alternating series 10.6. Now this one is going to be a little bit different than what we had so far because it will have two types of convergent series. It will have absolute convergent and conditional convergence. So we'll have to figure that out. And this one has a process rather than something. So you are remembering the process, and I like to put that process in a diagram form, like a tree, like branching, okay? So first of all, for alternating series, we have this -1 to the n times an. Let's start at 1 or whatever and go to infinity. So we know it's alternating series when we see -1 to the n. It could be -1 to the n, -1 to the n plus 1. It could also be cosine n pi, right? Because that's also going to generate -1 plus 1, -1 plus 1 as you plug in 0, 1, 2, 3, 4 for n. So all of these are terms that will show the alternation. Awesome. So we have that. Now, how do we work convergence or divergence? Well, it works like this. First, you look at just the sequence an. So you bury these two things, and you are only looking at the sequence. Now, what do you want to know about that sequence? You want to know if that sequence is decreasing and if limit an is 0. So that's what you want to know about it. If it's yes to both, you are going on a convergence branch. If it's no, it's divergent. Now you know that you spot divergent series when the limit is different than 0. So technically, if the limit is not 0, it's your nth term test, your first row on the sheet, right? Would kill this problem anyway. Awesome. So now we have that. And now if it's yes, you will look into summation of an. See, we never do anything with this -1 to the n. We start with a sequence, and then if it passes those two conditions, condition number 1, condition number 2. So if it passes number 1 and number 2, number 1, check, number 2, check. If it passes those, we are on a convergence branch. If it doesn't pass, then you are in divergence and you're done. And now, when you look at the series of an, that one can converge or diverge depending on what it is, right? If this is summation of 1 over n, it will diverge. If it's summation of e to the n, it will diverge. If it's summation of 1/2 to the n, it will converge, right? So depends on what an is. So now if it converges, it's going to be absolute convergence. And if it diverges, it will be conditional convergence. So absolute convergence and conditional convergence. And this is your roadmap. So there are 3 possible answers. Answer diverge, answer absolute convergent, or conditionally convergent. Now, it's worth mentioning, and we'll see the details of this when we do a couple of exercises. It's worth mentioning now that all of the convergence you had so far, and we covered 7 tests. Right? Convergence, all of the convergence so far was absolute convergence. We never called it that, but it was all absolute convergence. So this is your good old convergence as you know it. The new creature is conditional convergence that we would like to understand, and it only appears during the alternating series test. So when you go here for the alternating series test, conditions for convergence, there is an extra thing, right, that we would need, and that is summation of an to distinguish between the two types of convergence for these guys. So let's take a look at an example of this. So say you have summation of negative 1/2 to the n, starting from 0 going to infinity. So, okay, you, dare I say, clearly see that there is a negative 1 to the n involved in this mess. So we can split this into negative 1 to the n, 1/2 to the n, from 0 to infinity, from where we learned that an is 1/2 to the n. So your first job is to make sure that negative 1 to the n is separated, right? And if it's separated from the rest, then the rest is an. And that an is what you are going to use later on. So now we are going to start using this an. So is 1/2, right? An equals, is it decreasing? Yes, right? It's the decaying exponential, right? The graph would be dot, 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 dot. So yes. And is the limit 0? Yes, it's 1 over infinity, right? As n goes to infinity, this becomes the limit n goes to infinity of 1 divided by 2 to the n, which is 2 to infinity. 2 to infinity is still infinity, equals 0. So it passes both conditions. Because it passed both conditions, we hop onto convergence branch, and we are supposed to take a look at what's happening at this. So what's happening here? Excellent. It's geometric series. It's your second row on your sheet of paper. R is what?
Less than 1.
Less than 1, which means converges. So look at the sheet, right? R equals 1/2 less than 1, converges by geometric series, and then we can claim absolute convergence. So we say, answer? I can't write. Come on, computer. Since an is decreasing and limit an equals 0, and summation of an converges, series summation negative 1/2 to the n absolutely converges. That's it. So that is what we have. So an is decreasing and the limit is equal to 0. Those are the two conditions that put us on convergence branch. Once you have the convergence branch, then you work out your summation of an without -1 to the n part, and that one can converge or diverge. So if our converged, it goes to absolute convergence. If it diverges, it will go into conditional convergence. So again, an branches down into either divergence or convergence. If it converges, we calculate then sum of an, and that can either converge or diverge. If it converges, it is going to be called absolute convergence, and if it diverges, it's called conditional convergence. So that's the way, it's the roadmap, right? It's a little tree diagram, and you are going to go one of the three paths, right, to come up with one of the three possible answers. One more example, and then we are going to talk about conditional convergence and understand that better. So let's take a look at what we called earlier alternating harmonic series, right? That's one of the special ones. So alternating harmonic series, summation of -1 to the n divided by n from 1 to infinity. You should be able to work out this one on your own following the tree. Make sure you do the two conditions for an. If it passes the two conditions, right, and conditions for an are decreasing and limit an has to be 0 as n goes to infinity. Right, so those are the two conditions that have to pass, and then you have yes or you have no, meaning a condition failed. Obviously, if the series is increasing, as you add more and more and more increasing numbers that go to infinity, the sum has to add to infinity. And then we already have the nth term thing for the leverage over there. I'll close the copy so it's not getting full. So what is your conclusion for this problem?
It's going to be
Diverge, converge, conditional, or converge?
conditional
Absolute.
convergence.
Do you say conditional? Do you say conditional?
Can I have the book up the page?
Conditional convergence. So we are going to extract an, which is 1 over n. We are going to run the two conditions, decreasing, yes, and limit 1 over n equals to 0 as n goes to infinity. That's all bueno, right? And now we just have, so both conditions satisfied. That means we are running down the convergence branch. We check summation 1 over n, 1 to infinity, and we know that one diverges. So, since an is decreasing and limit an equals 0 and summation 1 over n diverges, series summation -1 to the n over n converges conditionally. Guys, it converges because it passed two conditions and it hopped on the convergence branch. Now, the series within it diverged. So now, we know that the problem overall converges because of that. And now we also know that the part of that problem diverges. So I hope you can actually now listen to the words, right? And what it means to have condition to do something, right? This problem converges under condition that this is present. If the alternating term is not present, series diverges. Put that alternating piece in, it converges, right? But it's not just converges as any convergence, because if you just have -1 to the n over n squared, well, that one you can't make diverge no matter what, whether you have, right? So that's the difference between absolute, right? When something converges absolutely, well, whether this is in or not, it doesn't matter, right? It's just absolutely convergent, and it's going to be absolutely convergent forever, regardless of whether you have it or not. But this one is a conditional convergence, because under condition this thing is in, converges, you take it out, it diverges. Right, so that's the reason. That's the difference between the two. There's obviously more, but that's the one that kind of makes the most sense with our talking points and all that kind of stuff.
So the absolute convergence would be without the alternating clause in it, like it would.
Absolute convergence is the convergence we always had since day one, right? The trick is that. In this case, we only worry about conditional convergence because conditional convergence is the one that is tricky, right? You remove the alternation, it diverges. You put the alternation back in, it converges. So it converges under condition that alternating term is in, right? But the other example that I put, which was the same, just with the n squared, that one will work out to be absolutely convergent, because 1 over n squared is convergent by p series. Now, whether you put the -1 on top to the n on top or not, it will always converge. Okay. Right? So that's the deal. Let's take a look at another problem from the book, and we would call it. I can do 2 problems from the book because they are so cute. And then that would be it for this one, and we are left with 2 tests after that. So let's take a look at summation -1 to the n 1 plus 1 over n to the n from 1 to infinity. What do we know about this one?
It's alternating.
Excellent. This is the first observation you have to make. It's alternating series test because it has alternation term in it. Yes?
A of n does not, the limit of a of n as n goes to infinity is not 0.
Beautiful. It's e, right? So our an is 1 plus 1 over n to the n, and then your limit of 1 plus 1 over n to the n is e, and that's different than 0. We're done. So this problem dies quickly, right? Now you can also claim divergence in this problem using the divergence test, the first row on your sheet of paper, also known as nth term. You can also put, you should write in the wording that we use in this book. So for the first row on the sheet of paper I gave you, you should have the title divergence test rather than nth term. Nth term is in the Larson book, and this book calls it divergence test. So the first row, you can have both names in there. And that one was in a section 10.4. Oh, you didn't write the numbers. So the first one is in 10.4. Geometric and telescoping are in 10.3.
Essentially on the picture, man.
Oh, P series is 10.4. Alternating is 10.6. Integral test is 10.4. Root and ratio is 10.7. I said last time I think 0.5, but that was the old book. 10.7 root and ratio, and the last two comparison tests, 10.5, we just did that, 10.5, two comparison tests. So now you know where they belong to, because they are not in the order we have them. One more problem, and we'll switch to the next one. Well, this is the one that it has, this is a good one. Cosine of n pi divided by n squared, right? You can start anywhere, 2 or 17, I don't care. Right, this is a good one because it has the cosine of n pi, and this is the one where you need to realize that's alternating. You just need to know it, right? Cosine n pi is alternating because what's cosine of 0?
1.
And cosine of pi? And cosine of 2 pi? 1. Right? So it goes 1, negative 1, 1, negative 1, 1, negative. So that's the alternation. So what's your AN? Y over n squared. Yes. So now you go your decreasing, you go your limit, you do the
It's an absolute convergence.
X. The absolute convergence. Yes.
Also, I do believe I can take you into something different. It slipped my mind that you do everything online, so I can just watch everything in the morning for the 6 hours before I go to work. So just catch up on the lessons the day.
the lectures are 3 hours and 15 minutes 4 times a week.
Yeah.
So Monday through Thursday.
I don't have work until 2 o'clock, so like I start leaving my house at 1 p.m. and I usually wake up at like 6.
Oh.
So essentially, I just take your class the day after and come in for exams. So yeah, I could do that.
So we have now our AN. It's from here is a decreasing. Yes, limit 1 over n squared equal to 0 because you're dividing 1 by infinity. So we are on a convergence branch. Now you do summation of 1 over n squared, and that's convergent by P series. And for our problem, we claim absolute convergence. Cool. That's it. That's it on alternating series. Please bring this thing up during your Thanksgiving dinner.